In 2016, ECRF and Parkland College were involved in a large flax study led by Chris Holzapfel from IHARF. Dr. Jeff Shano from the University of Saskatchewan was also brought on board as a co-investigator. The project will run for another 2 years, at which time Chris will write up the final results from the study. The objectives of the study is to evaluate the yield response of flax to various rates and combinations of nitrogen and phosphorus fertilizer. It was considered worth revisiting this kind of study because producers have been frustrated with inconsistent yields with flax. The rates evaluated in this study go beyond what are typically recommended for flax. Nitrogen rates range from 13 to 150 kilograms per hectare, and phosphorus rates range from 0 to 60 kilograms per hectare. Every trial tested a factorial combination of the 4 nitrogen rates and 4 phosphorus rates. In other words, the 4 rates of phosphorus were compared at each rate of nitrogen, which gives us a total of 16 treatments. These treatments were then replicated 4 times, and all fertilizer was side-banded. The trials were conducted at 8 sites from Vegreville to Brandon, and were run by various research organizations listed in this slide. Due to heavy and widespread snowfall early in October, harvest was delayed late into the fall at Melfort, Swift Current, and Vegreville. This reduced yields and test weights and increased variability in the data at affected sites. The results from Melfort in particular have been left out of some of the analysis. Increasing rates of phosphorus did not significantly affect flax emergence. However, increasing rates of nitrogen did reduce emergence at Scott, Swift Current, Yorkton, and Brandon, which have been bolded in this figure. Even though the fertilizer was side-banded, inadequate separation of seed and fertilizer caused a significant stand reduction. This demonstrates the sensitivity of flax to the toxic effects of urea. However, with the exception of Scott and Swift Current, plant population still remained above the minimum recommendation of 300 plants per square meter. Producers who are wishing to push their nitrogen rates with flax may also wish to consider increasing seeding rates to compensate for the loss in emergence. Added phosphorus didn't significantly affect maturity of flax. In contrast, increasing nitrogen rates significantly delayed maturity by approximately 2 to 5 days, depending upon the location. While maturity in flax can be an important consideration, since flax requires a relatively long growing season, the observed delays coincided with higher yields and were unlikely to result in a significant agronomic challenge. Yield response to added phosphorus was significant at Indian Head with a yield gain of almost 5%. Conditions were best for observing a response to P at Indian Head, as the site was high yielding and the soil was low in residual P. Yield did not respond significantly to added phosphorus at any of the remaining locations, which supports past research and grower experience. While flax may be a good scavenger for phosphorus, this does not mean phosphorus should be routinely omitted when growing flax. On the contrary, phosphorus should still be applied to maintain adequate levels of soil phosphorus for long-term crop productivity. Soils with depleted reserves of phosphorus cannot be compensated for in one season by applying high rates of P fertilizer. All sites, with the exclusion of Melfort, significantly responded to increasing rates of nitrogen. Generally, yields were maximized between 100 and 150 kilograms per hectare of N, which is somewhat higher than what past research would indicate. The magnitude of the response was quite variable and ranged from 13 to 115%, or, expressed another way, 3.5 to 19.5 bushels per acre. Overall, yields at Swift Current, Vegreville were lower, where severe weather had hampered harvest. The average yields of the remaining sites vary between 2,100 and 3,300 kilograms per hectare, or about 33 to 53 bushels per acre. So, in summary, responses to N were consistent, and in some cases highly responsive to relatively high rates of nitrogen fertilizer, in excess of 100 kilograms per hectare. Responses to pea fertilizer were much less frequent, and when they did occur, much smaller. Again, this doesn't mean we shouldn't be fertilizing flax with phosphorus. Soil reserves of phosphorus need to be maintained for long-term crop productivity. Plant populations were frequently reduced by high rates of applied nitrogen despite all the fertilizer being side-banded. Populations were not affected by increasing rates of phosphorus. So this shows that flax is sensitive to the toxic effects of urea, and producers targeting higher rates of nitrogen should also increase seeding rates to compensate for the loss. Nitrogen delayed maturity by 2 to 5 days, but this delay coincided with higher yields and was unlikely to create agronomic challenges. Phosphorus rate didn't affect maturity. I didn't show the data, but there were some nitrogen fertilizer effects on test weights. However, the effects were inconsistent and relatively small. Well, that's it for the flax study. Thanks to Chris with IHARF for leading the project. Funding for this continuing study is being provided by the Saskatchewan Agricultural Development Fund, Saskatchewan Flax Development Commission, and the Western Grains Development Commission.